Why, thank you. Oh, thank you all for being here. It's good to be here with you. I think I know most of you, but I should probably introduce myself for those of you that don't know me. My name is Mark Graham, and I am the suit tonight. That makes me the Chief Executive Officer for Loud Technologies, for those of you that don't know me. And I have to begin by making a confession. I'm actually not a good CEO because really what I am is a gearhead. I absolutely love audio gear. And, you know, for some of you, maybe even in this room, in fact, I know a few of you, how you have a passion for cars, or maybe it's nice watches, or you name it, golf clubs, whatever. But for me, it's sound gear. And nothing feeds my addiction. Nothing satisfies my gearhead side like EAW and like what we're going to get to show you tonight. So I have to tell you, I'm really excited to get to be here on this night with you, what I think we will all look back on as a pretty historic time. The system we're going to show you is something special. It's been an absolute thrill for me to get to be a part of the process of bringing something like this to life. It's so interesting, so well engineered, so designed to such infinite small detail that we even had to give it a name. And I had a great question at dinner. You know, okay, well, how did you come up with a name? Not the best question for me. Ask the EAW crew. But I want to tell you, it's an interesting part of this system in that as it came together, we realized that there was too much there to just give it a model number. We couldn't give you another KF Infinity. It had to have something that spoke to the fact that there's this system is almost sentient. It is self-aware. It is adaptive. It is really exciting. And I can't wait for you guys to get fully introduced to Anya. So I want to say, before I exit the stage, how proud I am of the EAW team. Guys, I hope you fully understand what it takes to bring something like Anya to life. This is an effort that is Herculean. It is of a scale that is hard to comprehend. As it loud, you know, our goal is not to just make sound system products. We want to lead. We want to have the products that define the spaces that take our art, all of us together, to new places, to new heights. And I am so proud of what the team has been able to accomplish in this. EAW is really, it's what I joined Loud for. It's heart, it's passion, it's soul, and it's really what the EAW team is all about. And the leader of that heart and passion and soul is a man I'd like to bring out and introduce you to now, is the president of Eastern Acoustic Works, Jeff Rocha.
Well, welcome everyone. First, I'd like to it's very funny, guys. You know, it was all fun and games during rehearsals, but you may not have noticed we actually have guests here this evening. So why don't we just cover the room so that they can all hear me, and we can continue with the presentation. Are we good? Can you hear me now? All right, well, first I'd like to thank you all for joining us tonight and welcome you to an evening with Anya. Tonight we have an all-star lineup of EAW staff who'll tell you the story of Anya and what makes this sound system so amazing and unlike anything that has come before. Now, no matter what vertical market you work in, you all share a common experience. Rooms. Lots and lots of rooms. And for each and every one of these rooms, there's an idealized acoustical source. I'm sure that you can almost envision that optimal source whenever you first walk into a space. There exists a coherent, three-dimensional wavefront that would perfectly paint the audience area with spectacular audio. And creating that wavefront is a bit like creating a work of art, like a painting. The challenge is that the best that you can realize is an approximation of that ideal, because you're forced to paint with geometric building blocks of sound, a bit like audio pixels. So the work of art looks a bit more like this. And to make matters even worse, in your world where pixels meet, they generate new and interesting colors, as interference adds yet another layer of complexity to your craft. Now at EAW, for these very reasons, our philosophy has always been that the optimal solution is a custom design solution that is tailor-made to solve the very unique requirements of a specific acoustical space. And we've actually developed lots of these customized solutions in partnership with many of you who are here with us this evening. In addition to that, we've created the industry's largest set of standard order loudspeaker systems so that you can choose the tools that allow you to most closely match your idealized solution. Now, this collection of tools gives you a tremendous amount of control and flexibility and allows you to create a more precise approximation of the ideal, but in the end, a gap between the ideal solution and reality remains. Now, some products that we've developed, like the KF900 and the DSA series, allow an even greater degree of flexibility, but only in 2 dimensions. So almost a decade ago, we started to ask ourselves, could we create a system that would deliver optimal 3-dimensional solution to any environment? One that could adapt its directivity to meet the requirements of any room. Could we create a system that would give you the ultimate flexibility to paint, to create works of art without compromise or constraints? And the simple answer is yes. Yes, we can, and yes, we have. Almost a decade under discussion, and over 3 years in development, the concept of adaptive performance, now manifest here in Anya, combines almost all of the major aspects of EAW's historical technologies, in addition to many new and exciting innovations, into one comprehensive system that can become, in effect, almost any loudspeaker system that you could possibly need. So at this point, I would like to bring out EAW Engineering Director Nathan Butler to discuss the details of the architecture of Anya. But unfortunately, Nathan was unable to make the trip to be with us this evening. So I've asked Gerald Stevens, our Director of Education and Support, to join us to discuss the architecture of the Anya system in much greater detail. Gerald.
Thank you. Good evening. All right, everyone, buckle your seatbelts. It's about to get to be fun here. Thank you so much for being here with us for our event tonight, and we appreciate you taking some of your time to be with us this evening. As Jeff mentioned, this ideal solution the engineers envisioned would have the ability to adapt 3-dimensional directivity to perfectly match the requirements of any room and optimize the response over the coverage area across the entire audible frequency range. EAW engineers began discussing this concept back when we released the DSA series of products over a decade ago. Now, while DSA opened the door to the practical application of the 2-dimensional concept of beam steering, the practical constraints of technology in 2002 wouldn't support the ability to deliver a self-contained system at the level of performance and at the physical scale of Anya. Now, we all know that the near to far throw well, that's a hard word, John. Differential in almost any application is far greater in the vertical plane than it is in the horizontal plane. This fact alone is likely what has driven the predominance of the existing line array format in our industry. In order to approach the ideal, we would have to employ something akin to the 2-dimensional concept of beam steering in the vertical plane, while relying more substantially on a horizontal array in the horizontal plane. But they wouldn't stop there. the engineers imagined the optimal solution as something that closely approximates an arced horizontal array of very long vertical ribbons of sound. They would have to have discrete control of very small segments of each ribbon. Now, if we were to start with a three-dimensional model of a space, and I said if we start with a three-dimensional model, thank you, and then project the idealized three-dimensional wavefront back to the source, then you can likely see how we can make these adaptable ribbons of sound shape-shift to very closely approximate the three-dimensional ideal. Now, it's one thing to imagine, it's quite a different thing to actually create it. And the first known factor in the development process was the ideal spacing of high, mid, and low frequency sources. The goal was to change or better control vertical directivity and eliminate the need for downfills or physically arcing the array. Now that meant the devices had to be very closely spaced together. Anya would need small drivers that were capable of extraordinary output and extraordinary fidelity. Of course, EAW engineers had never tested or even heard of such a device. So they did what they always do when they encounter such a challenge. They asked Kenton. So now let me introduce EAW's technical founder, development guru, and Parnelli Award winner, Kenton Forsyth. So Kenton, tell us about these high-frequency drivers.
Well, thank you, Gerald. So the good news was that using small format high-frequency devices is fundamentally better for high-frequency reproduction. The absence of diaphragm breakup modes and the larger diameter phase plugs makes the impulse response ideal. So simply put, they just sound sweet.
The small format devices let us use our preferred diaphragm material, which is aluminum. We like it for its internal damping and warm sound. Larger format drivers require exotic materials to reduce the breakup modes inherent in the design.
So Nathan and his team devised a horn throat geometry that would allow for 1-inch apertures and 1-inch spacing for the entire length of the array. Well, then I had to go and find a driver that actually worked in this architecture. In my current role at EAW, I focus a lot of attention on transducers, having developed a series of close relationships over the years with the world's finest transducer manufacturers and engineers. But it indeed was a challenge to develop a high-frequency component that had the output, the small size, the necessary bandwidth, and of course the excellent sound we needed for Anya.
We needed small size to allow very tight pack and low resonance to allow a relatively low crossover transition from the mids. And of course we needed excellent sound quality. Now to be clear, a 1-inch driver spacing meant that the maximum measurement of any driver could be no more than 1 inch. No driver of that size would do what we needed. So we moved to having 2 columns of drivers.
So we turned to one of our key partners who had the basics of what seemed to be a workable design. Their small format high frequency driver delivered many of the qualities we were looking for. However, the neomagnet structure that was used in order to get the flux sufficiently high was too large in diameter. They, however, worked with us to develop a new structure, retaining the flux, but squeezing it somewhat to fit our tight center-to-center constraints. They also created new tooling that allowed the structure to be integrated with companion drivers, and the resulting component is roughly 2 1/8 inches high, stacked 7 high within the height of a 15-inch woofer.
But 2 columns of 7 drivers was not our goal. We needed a horn with a single column of 14 cells.
Well, again, Nathan and the engineering team developed a system of staggered apertures for a dual line of these components to reduce the center-to-center aperture to more like 1 inch, thus allowing the extremely precise and radical steering, like the nearly 90 degrees downward we can get here at the House of Blues. The result is a 14-element source of 35 millimeter voice coil drivers, aluminum diaphragms, gives us high output, high power handling, and actually similar to 6 of the commonly used 3-inch coil drivers, and a very excellent sound character. So the small diaphragms move breakup modes beyond 16K, and the sonic character of the aluminum with inherent damping really comes forth. And furthermore, a bit unusual in compression drivers, they have an elastomeric surround material that provides excellent damping.
So this fundamentally solved the high frequency challenge, so the rest was pretty easy.
Oh, yeah, of course. Not quite.
Well, the use of the small format high frequency device means that we have to ask even more from the mid-range element. In many ways, this harkens back to Kenton's first designs, where the core goal of the now famous mid-range horns was to keep the entire vocal range in a single transducer.
But for Anya, the device size was again driven by the requirements to radically vary the directivity over the entire bandwidth of the device. We used 3 closely spaced 5-inch mid-range elements to provide the appropriate spacing and couple well with the 14-element high-frequency array, and of course 15-inch woofers, as a submultiple of them.
So placing an array to either side of the high frequency section allows for the optimal horizontal spacing to maintain horizontal pattern control within the horn. But it places 6 cone transducers within the horn, a high frequency horn. So this presents 2 familiar challenges.
Well, first, the impedance of the horn itself acts as a low-pass filter on the mid-range. Makes it difficult to combine smoothly with a high-frequency section. And second, I mean more importantly, the geometry of the cone transducer disrupts the surface of the horn in a manner that, simple features like slots and that do very little to repair.
Fortunately for us, EAW has patented technologies that directly address both of these challenges, and both are uniquely applied to Anya. The radial phase plug that was first introduced for the KF750 optimizes the loading of the mid-range, thereby improving the mid to high transition. CSA technology, first applied to the coaxial device in the AX series, minimizes and randomizes the size, shape, and location of the mid-range apertures. Again, it minimizes the impact on the high-frequency wavefront, further optimizing this transition.
With the engineering team work on the mid-range loading, we still needed the best 5-inch component possible. So a different key supplier rose to the task. Resulting design uses as strong a neomagnet structure as we can fit on the frame, and is driving as large a voice coil as we can fit to the cone. The result is high sensitivity from the very strong neomagnet and high output from the high power handling we're getting with the coil. So the resulting device is housed in a custom design cast aluminum chamber to provide optimal loading and to act as a heat sink on the magnet structure.
Okay, well, that was a little complicated, but the low frequency section, I mean, it's a pair of 15s. What's complicated about that?
Well, we still can do better. It requires a lot of attention to every detail to maximize the performance of the system. The low frequency is really the foundation of everything and provides the impact, kind of the oomph on the bottom end.
The engineers had decided to base the system on a dual 15-inch low frequency design. Again, the key was spacing, but horizontal spacing. The lows needed to complement the mid and high frequency elements in the horizontal pattern control, as far into the base region as possible. But the enclosure also had to pack efficiently in a truck.
Well, yeah, we didn't want to make a truck an accessory needed for the system, so it's good to be compatible with ones that already exist out there. But we've had experience with outstanding woofer design. Again, working with another one of our key suppliers, we had developed what we consider to be the world's first real 10-inch woofer for the 740 system. This is probably the first woofer that used a split-winding coil design that allowed for a very linear BL curve over a wide excursion range. But for Anya, we brought this technology to a 4-inch coil 15. This uses a 32-millimeter coil winding, much longer than any other 15 we're aware of, with plus or minus 12-millimeter linear travel range. It was previously unknown. The neomagnet structure provides both a relatively lightweight and high BL for a strong impact.
So you designed a killer component, but the engineers couldn't just drop them randomly into the baffle and go home for dinner, as nice as that might have been.
Well, no, these woofers needed to load into the cabinet in a somewhat offset manner to retain the optimum cabinet size, going back to the truck pack, and the aperture spacing relative to the mid-range elements.
But unfortunately, getting the system into a truck in an efficient manner pushed the woofers a bit closer together than would otherwise have been ideal.
Well, driver spacing relative to reproduced wavelengths means everything when designing for directivity. Although I feel I've been repeating myself. I think we did this in conjunction with some people, I don't know, 15 years ago or more. But for Anya, Nathan's team, again, created these apertures that are offset several inches wider than the transducer spacing. This both extends the uninterrupted surface area of the horn, but also push the apertures, the origins of the low-frequency sources further apart. This delivers consistent horizontal directivity and translates beautifully to the pattern control of the mids.
So you're saying that you have the highs closer than physically possible, and the lows are farther apart than physically possible.
Yes, well, strange as that seems, that's correct.
Well, doing the impossible is all in a day's work at EAW. So thank you, Kenton. You're great.
Thank you.
One note on the low-frequency apertures as they relate to the horn flare in the horizontal plane. By minimizing and dispersing the openings for the low-frequency energy, they become essentially invisible to the mid-high wavefront. So despite having two 15s placed within the enclosure, the horn fills the entire face of the enclosure. This classic EAW design gives us idealized pattern control in the horizontal plane. As complex as it is, it's only one example of the exacting detail required to make adaptive performance real. And again, we say this over and over. In an adaptive performance system such as Anya, device resolution is the key. Now, the choice of name for our software platform is no accident. In order to radically alter the shape of a wavefront without negatively impacting the impulse response, you have to achieve spectacularly high resolution and discrete control of every element. This allows the relative change between adjacent elements to be very small, while the overall impact of this over the entire surface of the array is large. Just like Jeff's original description of a pixelated image, in order to have clear, natural, musical audio reproduction, you must have extremely high device resolution. Now, all that work on the Anya acoustics package would have been pointless if we could not deliver discrete processing to every element. So let's talk a little bit about the electronics package. Each module has 22 devices. It requires 22 channels of signal processing and amplification. The amplifier components were developed in partnership with our friends at PowerSoft. And the associated algorithms and DSP are all EAW. The audio network and bidirectional communications are on the Dante platform from Audinate. Anya is only possible thanks to the enormous leaps that we've seen in DSP, amplification, and networking in terms of speed, power, and size.
So now that we've discussed the architecture of Anya in much greater detail, let's explore Anya in use. We've created an extraordinarily flexible tool, so now it's your turn to truly optimize the performance of Anya to perfectly meet the requirements of the world's most important venue, yours. We spent considerable development time approaching the application of Anya from the perspectives of all of the different people that will interact with both the loudspeaker product and the software application. We've layered in countless features to make this extraordinarily sophisticated product extremely easy and intuitive to use. So now, I would like to invite Bernie Broderick, our technical training manager, to join Gerald for a closer look at the application of Anya.
Hello.
Hi, Bernie.
Hey, Gerald.
I'm really glad you're here.
We were playing around today. We were doing our thing, and we thought it sounded like Two Guys Garage. You ever seen that show? All right.
One of the things we learned when we studied the Anya use case is that different types of users approach design and work in different ways.
A system designer with time and proper room drawings will want to do this work in advance using resolution, but you don't always have the time or the proper room drawings. In that case with Anya, you could simply fly the rig out in advance and take care of it from there.
The point is, we don't force you into a particular workflow. Anya works the way you do.
Right, so Gerald and I are going to describe some of the features designed to let each of us work with Anya the way we would like. Gerald, I know where you'd like to start. In resolution.
Absolutely. You know, I would. Even the name of the software, resolution, reflects on our focus on creating a level of control and precision that users can trust to deliver predicted results. I'm certain some of you have already noticed some of the major advances we've made with Resolution 2. Obviously, it now lets you model in a natural three-dimensional view. Also, it now supports horizontal arrays. Now, horizontal array ability really didn't apply during the age of the line array, but with a system like Anya, it's essential. And finally, and you can breathe a sigh of relief, Bernie, Resolution 2 incorporates all of the control functions of EAW Pilot, so it can deliver signal processing settings directly to the loudspeakers. Many of the design elements will remain familiar, creating venues, creating arrays, assessing load ratings, but we've streamlined the process, the workflow, wherever we could, with the goal of making your work easy and quick.
Gee, Gerald, that's swell. But what do I do when the truck backs up to a venue that I've never seen for a show that's going to line check in an hour?
Well, golly, Beaver, I suggest you get some PA in the air.
Exactly. Resolution 2 is awesome, and I spent hours tweaking the model for this particular venue. But Anya and Resolution let you define your coverage after you've flown the rig.
To be clear, Bernie's time constraint of 1 hour to fly arrays like these really is not that big a challenge. Anya represents a big step forward in the speed and simplicity of physically assembling the arrays.
Because the arrays hang straight without any J, you're never going to have to deal with any box angles. That means we could create a simple, safe rigging system that's designed to work exactly one way.
And even though you can't see the rigging, we have multiple fail-safes in place to ensure complete engagement.
Basically, if the rigging handles are driven all the way home, it guarantees the rigging is fully engaged. It's all mechanically driven. It can't not work.
Likewise, the fly bar always sits level. We do offer 4 options to pick it up from 1, 2, 3, or 4 points. But you never have to calculate which pickup point will give you which up or down angle.
That's because there are no angles.
Woohoo!
It's really quite liberating. So connect the fly bar to the motor. Hoist away.
Now, I hope some of you are wondering how Bernie can be so sure those modules actually work before he flies them in the air.
Ah, he says that facetiously because he knows we checked each and every module as we loaded them onto the truck last night. Anytime, anywhere, not even plugged in, you can test a module by pushing on the power unit, button on the power unit that says test. That's Mickey right there. Green means go.
And with the arrays in the air and powered on, we need to figure out which module in the array is which module in the software.
Right. Remember that whole tedious process of pinging each module to see which one was which? What a drag.
Yeah.
Instead of that, how about if Anya did it for you?
Wow, each module's power and processing unit includes an infrared transceiver in all 4 sides. As soon as the power is turned on, each module starts talking to each other.
Anya recognizes each individual module and the array as a whole, and then presents that information to resolution. And it all happens in the time it's going to take you to walk from here to front of house.
Me?
Absolutely.
That's the level of detail we brought to Anya. We also spent a lot of time developing the right architecture for AC power, network connectivity, and signal processing and signal.
Right. You can see that we only used familiar standard connectors, nothing obscure or custom, and you could choose from a number of ways to deliver your audio.
Our preferred method is to deliver audio and network connectivity on the fully redundant Ethernet connections. But if you have an analog signal, you can deliver it via XLR cables, or you can deliver digital audio via XLR using the AES EBU standard.
Like the workflow, Anya lets you to deliver the signal your way.
Sounds great, but on behalf of all these people here, let me ask how exactly you define the coverage after you've flown the arrays.
Well, it's through the magic of trilateration.
Boy, that's a big word.
That is locating a point in space by determining its distance to 3 other points with known locations.
So resolution only needs to know the trim height of the arrays and the distance between them, but that's all.
Correct. Once resolution knows those 2 things, here's what you do. Put a test microphone connected to smart software at the end at the point you're trying to locate. Anya will deliver 3 bursts of sound from the most widely separated modules in the array. Based on the arrival times of those 3 sound bursts, Anya can locate that microphone within a few inches. Now, simply repeat this around the perimeter of your coverage area, and resolution will plot these locations. Voila, you have a coverage zone.
Anya will then adapt the array performance to create the ideal 3-dimensional wave surface for that area. It's really just that simple.
It really is.
By way of conclusion, Bernie and I are going to talk about a few scenarios you might face and show you the features we designed into Anya to make your life easier. Let's say a transducer failed during sound check, and Anya gives you multiple options to deal with that.
Right. In fact, Anya alerts you to the failure. Anya regularly compares each transducer's impedance to a reference stored inside. When they don't match up, Anya's going to let you know. The odds are that you won't have time to switch the driver, but Anya will already have calculated signal processing to heal the gap left by the non-functioning transducer. But she's only going to change that on your order. Now, let's say it's even worse. Let's say you do have time to change the driver.
But Bernie, the driver is in a module that's in the middle of the array.
If you can get to the driver and the module, you can swap it out. And you can do it using regular tools while it's hanging in the air.
As a primary design constraint, we made it so that everything in an Anya module comes in and out either through the front or the back.
Right. And then when you get back to your shop, you can quickly, easily, and very precisely test the unit. Each module includes a built-in measurement microphone so you can run sound bursts on each transducer and compare the response not against a generic reference curve, but against the actual measured response for that specific transducer.
As part of the QC process for Anya, we measure each transducer. and store those curves as reference inside the module's internal memory. If you replace a driver, measure the response and store the new curve as the new reference.
Right. Oh, I could go. Okay, I could go on and on about the cool features designed into the Anya system, but Jeff's over there giving me the signal. I just want to say Anya gives you everything you've ever asked for in an array system, and it gives you a few things that you didn't even know you could ask for. From the heart, Anya is by far the most advanced, most fully thought through, most amazing product that I've ever worked with, and I am personally proud to have played a part in it.
I know how you feel, Bernie. It's really a once-in-a-lifetime experience for me. So that wraps up our discussion of applications. So what's up next, Jeff?
Bernie? Nope, I'll turn my mic on next, yeah. Thank you. All right. So now we'd really like to show off what Anya can do. Enough talking about it. So we're going to do some tricks with the coverage. We'll go through a sequence during 2 tracks, starting with a special setting that I'll talk about in a minute. And then we'll return to covering the room. Halfway through a track, we'll then shift to just covering the balcony. Start a second track, return to covering the room, just cover the floor then. Just this floor area here. And then again, we'll return to covering the entire room before adding back in the subs and the front fill to prepare to kind of elevate the volume levels as we move throughout the evening, kind of culminating with our live band. So during this demonstration, you can either choose a place to listen and experience the coverage kind of coming and going, or you can run around the venue chasing it. Just be careful. No running with scissors. But if you keep an eye on the screen here, we'll tell you what track is playing and also what kind of adaptation of coverage is going on at any point in time, so you know generally where things are. Now to start, we're actually going to open the vertical directivity of Anya up to nearly a full 180 degrees of vertical coverage. So you can walk right up underneath it and hear what that sounds like, but perhaps more importantly, we'll also be sending a lot of energy up towards the roof, which I'm sure most of you would agree is not a great idea. But it'll allow you to hear kind of the room. This is a pretty good room, but you'll still be able to hear the contribution of the room to the overall tonality. Then about 30 seconds into the track, we'll pull it back in to an optimized directivity, and you'll be able to hear the impact of the room as it's minimized. So I guess that's it. It's time to play tracks. Take it away.